Imagine you're watching a video right now, maybe on your TV at home, your computer at the office, or your phone while sitting somewhere private. Every second, millions of pixels light up your screen, delivering high-definition images and rich stereo sound, all coded with billions of bits streaming through the internet. Mobile devices, smart TVs, and high-speed internet have made this so seamless it feels trivial. But the engineering behind getting those images and sounds to you instantly, almost anywhere, is a remarkable feat. The appearance of a buffering symbol, even on mobile internet, is now considered a failure of the streaming service, a challenge we faced while building our own platform, Nebula. I'm here to tell you not just why Nebula exists, but how it exists, because it's something I helped create. When we started Nebula, it was an experimental side project without a dedicated team of engineers. We built the first version using a white label streaming service called Psy, which allowed us to launch a worldwide platform in just a few months. But Psy wasn't designed for the complexity of managing hundreds of channels, releasing hundreds of videos monthly, or streaming to hundreds of thousands of active subscribers. As Nebula grew, we outscaled their capabilities and realized we needed a custom-built system from the ground up. This technology has advanced dramatically in the last decade, and I'll explain how it works. If you were born after 2000, streaming video might seem unremarkable, but in the early internet days of the 1990s, it was unthinkable. In 1999, the trailer for Star Wars Episode I, The Phantom Menace, broke records with over 1 million downloads in 24 hours, not streams, but downloads, because streaming a trailer at any decent quality wasn't possible with dial-up modem speeds. Back then, most people connected to the internet via telephone lines, which offered painfully slow speeds measured in kilobits per second, not the megabits or gigabits we expect today. Modems worked by modulating a digital signal into an analog sound wave over copper telephone wires, high amplitude for a binary 1, low for a 0. The transmitting computer modulated the data, and the receiving computer demodulated it, hence the term modem. This process, used in most physical cables except fiber optics, was prone to signal loss over copper, capping speeds at 56 kilobits per second in ideal conditions. For context, a 720p YouTube video requires about 5 megabits per second, 90 times faster than a dial-up modem could handle. By 2005, broadband connections like cable modems became more common, laying the groundwork for 3 guys in Northern California to launch a video dating service called YouTube. That same year, when Justin Timberlake and Janet Jackson's infamous Super Bowl halftime wardrobe malfunction happened, the trio couldn't find a video of it online, so they pivoted YouTube into a digital video repository anyone could use. Nearly 2 decades later, home internet speeds have soared. But mobile internet has become so fast it often rivals dedicated home connections. The smartphone revolution has pushed cellular data speeds to new heights by using more frequencies and innovative ways to pack data into them. We now have the technology to send data over long distances quickly, but that's only part of the challenge. When you click a video, you expect it to play instantly without buffering. That's possible if the video is stored on a server near you and you have fast internet, but not everyone does, and solving those edge cases is where smaller platforms like Nebula must be strategic. Bandwidth is the primary constraint. While high-speed connections are common in the Western world, not all users have them, and even those who do can face issues. A poorly shielded microwave can disrupt Wi-Fi, internet providers may slow down during peak usage, or a subway tunnel commute might cause signal loss. To address this, servers encode videos multiple times at different bit rates, the speed at which data must be transmitted to avoid buffering. Lower bit rates require lower resolutions to maintain watchable quality, as high-resolution videos at low bit rates look blocky and distracting. The transcoder creates files ranging from low-quality, smaller versions to large 4K files. When streaming, the video player downloads chunks of the file, not the whole thing, allowing it to switch to a lower resolution version if your connection slows, then back to higher quality when it improves. This also lets you resume a video from where you left off without downloading the entire file, saving bandwidth costs since most videos aren't watched to completion. For Nebula Sterilite system, we use fragmented MP4s to separate audio from video, Audio files are much smaller, and studies show poor audio quality impacts viewer experience more than poor video quality. By keeping audio quality consistent across resolutions, we ensure a better experience. Text manifests describe the timing and location of each video chunk, which the player reads to load the video. Once processed, these files are stored across multiple servers to ensure a copy is near the viewer. Contrary to popular belief, storage and bandwidth aren't the most expensive parts of running a streaming service. Modern services like Amazon Web Services S3 and Backblaze B2 offer affordable storage. Nebula's 30 terabyte catalog costs less than $200 a month, cheaper than our production team's Adobe subscriptions. YouTube, with 3.7 million daily video uploads, likely pays less per video due to owning their data centers, but our costs remain manageable. After transcoding and storage, the next step is delivery via a Content Delivery Network (CDN). A CDN is a global network of servers placed to ensure one is near every viewer. When you request a video, the service connects you to the closest CDN server to start streaming. Nebula CDN fastly uses a 3-tier system: local nodes near you, catching servers with our entire catalog for quick regional access, and the origin data center with all original files. Duplicating every video on every node worldwide would be inefficient, so the system prioritizes new or popular videos. If someone in your region has already watched a video, it's likely cached locally, reducing buffering. For older or less popular videos, or in areas with fewer subscribers, you might experience a brief delay as the file is fetched. As Nebula grows, doubling direct subscribers in 2023, this issue diminishes. While storage and bandwidth costs are low, Nebula spends under $20,000 monthly to serve 300,000 active users. The real expense is hiring skilled engineers. Building this system requires front-end and back-end web engineers for the API and website, DevOps teams to keep systems running, QA testers to catch bugs, and product designers and app developers to support various devices. The client app, whether a web browser or dedicated app, renders video lists and thumbnails, while the server handles most processing to simplify development across devices. Bugs are easier to fix server-side, avoiding lengthy App Store approvals. Different devices demand different programming languages: Swift for iOS, Kotlin for Android, JavaScript and TypeScript for smart TVs, and even niche languages like BrightScript for Roku, making hiring challenging. App stores add complexity with their approval processes. For example, Nebula's LG Smart TV app took months to get approved, only to face removal in 46 countries due to vague religious and cultural content policy issues, with LG unresponsive to our follow-ups. Supporting diverse devices is critical. Nearly half of YouTube's views are on TVs, and Nebula must be available everywhere, from mobile apps for offline viewing to web apps for browser access. Some viewers even watch Nebula in their Teslas via the browser. Catering to varied devices, operating systems, screen sizes, and connection speeds from fiber optics to spotty cellular signals is a complex engineering challenge made to look effortless by our team. Nebula is a partnership between the platform and creators. The company provides the business structure, design, and engineering, while creators bring their vision. This ecosystem supports hundreds of thousands of subscribers, with retention rates second only to Netflix, driven by our audience's connection to our creators. To maintain this, we avoid venture capital, which could compromise our autonomy. Instead, we turn to our loyal subscribers, offering lifetime subscriptions. With 680,000 customers, many unlikely to cancel, a $300 lifetime subscription from each could raise $204 million to fund projects without external investors. This approach has been successful, allowing us to greenlight exciting projects, including creator-written movies, blurring the lines between Hollywood and creator-owned businesses. This channel has benefited immensely from Nebula's funding. If you've been subscribed for over 3 years, you've seen our production quality soar. From After Effects animations in our Logistics of D-Day series to advanced Blender and Cinema 4D work in our Space Shuttle series. Nebula's support has made us a world-class engineering animation studio. And we're committed to becoming the best engineering film studio online. Please consider signing up for Nebula monthly, yearly, or lifetime memberships are available via the link in the description or the on-screen button. Your support fuels our mission to create better videos and opportunities for creators.